Okay, in this video, what we're going to do is talk about variable scope. Now, we've done a lot of talking about variables. We've seen how we can declare them, how we can initialize them. We've even seen what kind of data types they represent. Basically, what kind of data can we hold within a particular variable. But we've never really talked about scope. And scope plays a very large role in programming. The bottom line is scope defines where a variable can and cannot be accessed from. You can look at it like this, where we can or cannot see the variable. Let's think of a scope like the scope on a rifle. Yeah. There we go. This is the scope we're looking through. All right, work with me. Pretend that is a perfect circle. Now, what is in that scope is what we can currently see. Now, when I say what we can currently see, what I want you to do in your head is replace that with what we can currently access, manipulate, etc. What we have access to. So right now, if I had a variable sitting over here, this variable would be out of scope. Can we manipulate it? No. Can't add anything in it. Can't change it. It's out of scope. Now let's say we have a variable sitting right here. Can we manipulate this? Yes, because it is in scope. Now, all because this guy is sitting over here at the moment and he's out of scope, does that mean he exists or does not exist? Well, that all depends. That depends on a lot of different things. And this video here is not going to dive all the way into if a particular area has been allocated on the memory just at the moment where we're at. We don't have access to that particular location.
Right. Scope doesn't control whether or not that variable exists. It just controls whether or not we can see it.
Precisely. So that's the whole idea. Can we see it? Can we access it? So, this could be X and this could be I. We're going to use X and I a lot, I'm sure, coming up in some of these coding examples. At the moment, I can say I equals 5. This is valid because I is in scope. X equals 6. And I can't see X. I can't do this. This would actually cause the compiler to throw out a nice little error and stop compiling. We can't run the application because we can't compile it. So, scope, very, very important. Now, what I want to do is go ahead and erase all this real quick and talk about 3 scope levels that I'm going to introduce you to. So, we've got private. Now, depending on what book you read, what white paper you read, or what article you find on the internet, you're going to find some of these terms a little different. So it really does come down to what you're reading. I'm going to provide you with the terms that I like to use. Private, and also referred to from time to time as class level. So class level. Because once again, these are the levels of scope. All right, now I'm going to talk about specifically what each of these mean in a second. Now, the second scope level is going to be method level. So, method level. And you've probably heard this before being referred to as local scope. All right, next and finally, we have block level. And this you may see from time to time being referred to as structure scope. All right, so what do they mean? Well, let me give you a quick overview, and then I'm going to write some code out, and I'm going to go through and I'm going to point out what kind of scope exists with each of the declarations that we create, and where we're going to run into some problems with scope with some of the things I'm going to try to code. And then I'm going to have Logan turn around and basically follow along over inside Visual Studio and demonstrate the compiler being very unhappy about some of the things we're going to try to force it to do. So first of all, what is private level scoping? Basically, this is variables that they're defined in a class, and they can be seen by all of the methods within that class. Okay. Now we can get a little bit more fancy. We can turn them into public. So these are our data members, and we can make them accessible outside of that class by another class. But we're not getting into that right now. We're just going to keep this very focused. So class level means we're going to create a data member, or a field, if you will, that is going to be visible in all methods within the class. And I'll demonstrate this in just a second. Method level. Well, we've been creating methods in the last 30 some odd hours between Volume 1 and Volume 2 of the XNA Xtreme series. And when we create methods, from time to time, we need to define variables inside the method. When we define a variable inside the method, it has method level, or what is known as local scope. Okay, that means it can be seen within that method. Okay, by anybody that wants to access it. But as soon as the method is over, once, let's say we've called the method, it's executing. When the method's over, it's it. That variable is now gone. So we no longer have access to that variable from inside another method. Okay. Finally, we have block level, or structure scope. And this is if we were to create a variable inside like an if statement, or inside of a loop, or inside just curly braces that are standing on their own within a method. This is block level. It is not local scope because it cannot be seen by anybody in that method that's outside of the block. And again, I'll demonstrate all of this right now. So jot these notes down, hit pause, jot them down, because here they go. Boom. All right. Now, some code that I've got for you. Let's see if I can throw all sorts of good stuff up here. Logan, what I'm going to do in just a second is have you make a class called, I don't know, example. You guys are going to find that I'm going to use some very creative naming here. All right, so inside of our example class, we're going to start out by creating an integer, I, and we're going to go ahead, after declaring it, we'll initialize it with the value 8. Okay, after doing that, we're now going to create two public methods. So let's go ahead and do that. So here we are with public void, because it's not going to return anything, and creative name. Method 1. Yeah. And inside this method, that means we need curly braces, so here we go. Inside this method, I am going to create another integer variable. We'll call it x. Now I'm going to create another integer variable, and we're going to call this I. Ooh, I's already been used. Well, we'll see more about this in just a minute. And then I'm going to initialize I. Let's go ahead and take I and set it to 15. All right, now I'm going to do something interesting that you have not seen us do before. I am simply going to create a block right here. So an opening curly brace, and I'm going to indent inside the block, and I'm going to create an integer called j. And I'm going to go ahead and initialize it to a value of 4. And now I'm going to close my block. All right, and then at this point, Logan, just to help on time and all, and also my poor wrist and hand, I'm not going to write out console.writeLine, blah, blah. That's a lot of stuff. I'm just going to say write, but you'll know what I'm talking about, right?
Sure, that's the way we've been writing all these examples.
That's right. We're going to just say write I equals, and I want you to write out what is currently being stored in I. And that will conclude the first method. Okay. Now we're going to follow this up with another public method. So public, won't be returning anything. So public void, and another creative name from deep within Buzz's head, method 2. Okay. And let's go ahead and set up an opening curly brace. And inside here, let's access x and set it to a value of 3. Now we'll simply, right here, we're going to write out what is in I. So I equals plus I. Okay. Now I'm going to turn around and we're going to do an if. So we're going to say if I is greater than 100, what are we going to do? If I is greater than 100, we're going to create a Boolean variable, so a bool, that is called isTrue, and we're going to set it to true. So we'll initialize it. Okay, and we'll close off our if statement. All right, there we go. And now what I want to do is coming right out of it, I'm going to go ahead and set is true to false. And then we can, now I'm just going to do this only for a second, but I can just pull this down and we'll close this method and we'll close the class. There we go. So if you've been carefully following along, executing this code inside your head, you will realize at this point that I have created the most useless class in the world. Actually, I've created a broken class. We're going to see that in just a second. But what I want to do is demonstrate these 3 different levels of scope that we were just talking about. So starting out with private level. Remember I said that the private level variable or scope is a variable that is accessible throughout the class. All methods can access it. And this is what I have done right here. Okay, so this guy, you know, Logan, I think right now, let me go ahead and undo that. If you guys don't mind, I'm going to come over here to Tools, and I'm going to grab an interesting color. There we go. And we'll put our tools back away. All right, now I feel better about this because it'll look better. So this guy right here, he is a private level. That means, once again, he can be accessed anywhere inside of this method and anywhere inside of this method. You'll notice that I am accessing it in here. So public eye, well, actually, I'm accessing it in a couple of different ways, but hang on, because this is going to get interesting in just a second. So just keep that in mind, private level. Now, let's drop down into the method. We have int x. This right here is a demonstration of a method level. All right. This means that x can only be accessed. It can only be seen inside the method 1. Take a look at this. I am accessing x down here inside of method 2. I have not declared the variable x anywhere inside of method 2. The only place that I have declared x is in method 1, meaning that it has local scope to method 1. That means that this is an error. Right, Logan?
Right, that means that method scope means local to a specific method, not all methods.
That's right.
But specific to the method it was created in.
So we're going to see in this particular case that x is out of scope. And we'll have to end up commenting that out to actually see this work. Now what we're going to do is we're going to turn right around, let's come back up here to method 1, and we're going to create another variable. But this is interesting here. We're doing another method level. Looking at it, you may think, wait a minute, isn't this going to cause a problem because we have already declared a variable way back up here that had private level scope. So basically, it can be seen in all of my methods within this class. So that I already exists. Now you're trying to declare I again. That's not a problem. By the way, that this guy's design, by the way, the compiler's design, the language is put together. Looking for the right way to say that. What's going to happen here is this declaration of I is going to basically hide the class level version of I. So the variable up here, this variable right here, is going to be hidden now inside of this method. Which means while inside of method 1, anything that I do to the variable I is going to be working with the variable I that is sitting on the stack right now for method 1. Okay, so basically there is a stack frame that's taken place, and that stack frame contains all of the local variables that are in play right now for the current method, and it has a slot in there for a local variable I. So once again, the class level, the data member I, that's defined all the way at the top, has been hidden because of this throughout this method. Is that pretty clear, Logan?
Right. What that means is that, just like you said, it's now hidden for this method. So as long as you're in this method, if you try to look at I or affect I, you're going to be affecting the method level variable, the local version of I, instead of the private one or the class level of I.
Exactly. So when I come in here and I put 15 into I am putting that 15 into this local I. Okay?
While the class level 1 remains unaffected.
That's right, which means it still contains the value 8. Now what I'm doing is I'm creating a new block. I'm doing that right here with this opening and closing curly brace. This allows me to basically create a block level scope variable. Okay, that means that variables that I want to, let's say, create right there on the spot, use, and then as soon as I come outside of this block, they're done. They're gone. They no longer exist. So this is what is being put together right here. I am defining a variable that has block level scope. So in execution, when we come through here, this guy gets declared, initialized. Now right here, we're at the end of the block. When we fall down here, it's gone. Okay? So once we're down here, right now this is being set to a value of I, but Logan, I'm going to have you change this. I'm going to have you do I and J. So I'll just have you change it a couple of times. If we change this to J, what we're going to get is an error from the compiler. Because at this point, when we get out of our block above and we execute this console.writeLine and we try to access this variable J, it is simply going to tell us that variable is out of context. It doesn't exist anymore. We don't have access to it. So doing a J right here will be an error. Once again, out of context. I, if we do I is going to be seen as being equal to 15 because, once again, we are dealing with the local variable I. Okay? So keep that in mind. All right, so that is a very close look at method 1. Now let's go ahead and move on down to method 2. The first thing I showed was x equals 3, and I explained that's an error because there is no declaration of a variable called x in method 2. It's up there in method 1, but that's irrelevant because method 1 doesn't exist if we have just called method 2. Okay, because right now that's in the moment. We're in method 2. Our scope, remember the rifle scope, is now pointed over method 2. So what can we see? What is inside here? And also our class level 1 as well. So there may be special cases where there are other variables that you can see, but in this particular case it's going to be private level. That is a variable that has been given scope throughout all methods. Alright, so continuing on. So the very next thing we're going to do, after commenting out the x equals 3 error that we're going to get, is we're going to do a console.writeLine, and we're going to write out what I is. And you're going to see that I is equal to 8. Since we have not declared a local variable named I, that means we can access the private level I that is defined all the way back up at the top. And when we declared it, we also initialized it with the value 8. So now if we come down here, we can access it because once again, this particular I has, well, I'm going to write it this way because this will make me happier. Class level scope. Okay. Now, moving on down from there, because we can see I, that means this is going to run just fine. Okay. Is I greater than 100? Well, we have access to the I. It currently has 8. But let's pretend that the answer is true. Well, if it is true, that means we're going to come in here and execute this line. And this line says create a variable called isTrue that is of type bool and initialize it to true. What kind of variable scope does this variable have? it has block, or in this case, structure level, but this is block level. What does that mean? Well, the same thing that we saw above, and that is when we fall out, if we turn around and try to access that guy again, we are going to get an error. So this right here is going to give us an error because is true once we finish our structure here, or once we finish our block for the if statement, that's gone. No longer exists. He now falls out of scope. So anytime we are dealing with these block level declared variables, they fall out of scope when the block is over. They do not have local scope. Local scope is a variable that can be seen throughout that entire method.
Right, and that means that no matter how deep you get into some block, you're still going to be able to see the variables that are local.
Exactly.
It's basically, it works forwards and not backwards, if you will. If you have something defined above a block or above a method, generally you can see it because it'll be local or private if it's all the way back up in the class. Things that are defined inside of methods can't be seen outside of the method. Things that are defined inside of blocks can't be seen outside of that block.
That's right. All right, Logan, now that I've gone over all this, let's go ahead and code this, and I want to demonstrate the few errors that we should see. So let's go ahead and pull up Visual Studio.
All right.
And let's go ahead and create a new console app real quick.
All right, we've got console app, create a new one. And, yeah.
Let's just jump on down and create a new class. And it's called Example. I'll just walk you through this real quick.
So jumping down below the class program, we're going to begin our own class called Example.
And we'll block it in real quick. All right, now let's go ahead and start out with a variable that is accessible to all methods. So it's going to be an int.
All right, int. We've got
I equals 8. So we'll initialize it to a value of 8. Now, moving down from there, we're going to go ahead and start our first method. So public void method 1.
All right, this is going to be a public method void called method 1. And then we'll block that in.
All right. So let's go ahead and create an int x.
All right. Int x.
Okay. Next line, int I.
All right. Int I.
All right. Next line, let's go ahead and initialize I to 15.
All right. I is set to 15.
All right. Next line, start a curly brace. So we're starting a new block. Now inside this block, int j is equal to 4.
Int j equals 4.
All right. And let's go ahead and close off the block. Now give me a console.writeLine.
All right, we'll grab console, tell it to writeLine, and then we need to feed out.
We're going to go ahead and say I equals, and we want to demonstrate that I is 15 and not 8.
Okay, so we're just going to say that we'll be displaying I. So I is equal to, then I'll end the quotes. We'll add on to that the actual variable I, and then we'll close off the writeLine.
Beautiful. And that concludes method number 1. So let's go ahead and jump up under that curly brace down there and start method number 2.
All right, so we'll jump below method 1. This will be the same public void.
And
it's
method
called
2.
Method 2. And then we'll block this in, jump to the block.
We'll start out with a nice illegal instruction with x equals 3. Terminator. All right, next line. Let's go ahead and do a console.writeLine.
Console.writeLine.
And let's show the contents of I once again. So same thing that we had up above.
Okay. As a matter of fact, just to speed things up, we could grab the entire line and paste that over here. So again, just stealing this line, so I equals whatever is held in I.
All right, very good. Now let's go ahead and jump underneath that and start an if statement.
All right. So if, open parenthesis, and then we'll
I
do
is greater than 100.
Like so.
And then let's go ahead and start our block for it. And now inside that block, go ahead and create a bool.
Got a bool.
And set it to is true. Or its name
give it
is
a
true.
name of is true. I got you.
Yeah, and set it to true.
So bool is true. We'll turn around and set is true to the value
true.
True.
All right, and Terminator. All right, up underneath the closing block, let's go ahead and set is true to false now.
All right. We'll attempt to set is true to false.
All right, now don't compile anything. let's go back up. As a matter of fact, let me grab just the mouse, and this is going to be you and I working together here. So we should have an error where? Well, we come down here, this guy gets declared, he's got private level scope, all is good. We come down into method 1. Method 1, we make X, we make I, and so that means we're going to hide this guy, and this becomes I within scope inside method 1, so he has local scope now. We set I to 15, that's beautiful. We then come down here and we set, basically declare J, and set it to 4, and this guy is going to be a block level scope, so he only exists in here, and we will change this right line to demonstrate this in just a few minutes, but we're going to turn around and we're going to write out the contents of I just to demonstrate that I does indeed contain 15 and not 8, so we should see written out to the console is the very first thing, I equals 15. Alright, when Logan calls method number 2, we're going to have X equals 3. Alright, here's what I want you to do. Go ahead and put a comment in there, and in all caps put error, because we don't have access to X up here. He's in a different method. He has local scope to method 1. No scope whatsoever to method 2. So we should see an error there. All right, then we're going to come down here and we're going to do another write line, but this time we have not hidden the data member I, that is the class level I up here. So since we haven't hidden it, we will be using the value that's in it. So we're going to get I equals 8. So far on our console, we're going to see I, as long as we call this method 1, then call method 2. We'll see I equals 15, I equals 8. Okay, then we're going to come down, and if I is greater than 100, we'll create this good, all nice, nice, nice. Come down here, set is true to false. Ooh, is true was declared back inside the block, okay? So because of that, as soon as the block's over, it goes bye-bye. So that means go ahead and give me 2 forward slashes and a capital error right there. So that is definitely going to be a problem. So we've got some problems in here. Let's go ahead and finish this off real quick. Back up in main, let's go ahead and create a new variable of type example.
Okay. So this will be a type example. What do you want to call it?
EX.
All right, EX.
I'm so creative tonight. All right, and then let's go ahead and create a new example.
Okay, so we'll say that EX is equal to new example, open closing parenthesis.
All right, and now what we're going to want to do is EX.method1. So we'll just turn around and call its first method.
So we've got, there's our method 1.
And then turn around and call its second method. All right. So when we compile now, we're going to have some errors. The compiler is going to recognize the fact that we are trying to use some variables that don't exist. They're not within context in the areas that we have them in. It's going to let us know that. Let's see if it lines up with what we've got commented in. So let's go ahead. We'll hit F6 to compile or to build this. All right, so first off, we're not going to worry about warnings because there's definitely things that are being created that we don't use. So let me grab my pen over here. So once again, we're not worried about X being declared but never used. Who cares? This is just for example purposes. The name X does not exist in the current context. Ooh. So if I double click on that, we win $5. All right. Well, I wish because we can go to Burger King with that. So we're going to comment this line out like I said. So that was good. Let's go ahead and hit F6 again. All right. So now we have another one. And this guy is, the name is true, does not exist in the current context. There it is again. Let's go ahead and double click on that. What do you know? We said we were going to get an error there because is true disappears. It's gone. It's out of scope once we come out of this block. So let's go ahead and comment that, Logan. Now let's build again. All right, so now we just have some warnings for some variables that we don't use. We declare, but we never actually use them for anything, which that's fine. Now I'm going to have you run it, and when we run it, like I said, we should expect to see I equals 15 because of the local scope here of I, followed by I equals 8 because of the class level scope right here. Let's go ahead and run it.
Do you want to throw in a read line?
Yes, we do. Absolutely.
Hold up. I'm going to jump back into main, and right after we run our example methods, I'm going to put in a simple
Otherwise, this is going to flash so fast you may not see it.
Dot read line.
Thank you.
And now we're ready.
And let's hit F5. So, what do you know? I equals 15. Beautiful. Because of the local scope of I and the class level scope is being hidden from I. or I is being hidden. Okay, and then I, the class level I, is being seen in method 2, and we're printing out the 8 that is in it. Beautiful. So there you go. Go ahead and close out of that. The only other thing that we can throw in, well, let's see. At this point, Logan, let's just freestyle for a minute. Hope you guys don't mind. If you're bored at this point, you're more than welcome to stop the video. But let's just talk about a few things. There are some other problems that we can run into when dealing with scope and the way that the compiler works. Let's jump back over here. First of all, what happens when we get parameters in? Well, simple enough. If we were to, for instance, let me do this real quick. I'm sure you guys won't mind if I was to come over here and take this and make it another very interesting color. That looks good. Just so we know this is a discussion part 2. All right, so this time around, what happens if we were to come in here and take in parameters? So right here, let's say that we brought in something like int k. All right, this parameter k would have local scope or method level scope inside of this method. Okay, it could be used anywhere inside of it. It could not be used up in method 1. It could not be used in any other methods that we added in. So keep in mind, all parameters that you add into a method signature, basically when you're defining the method, they only have method scope within that method.
Right, but they follow the exact same rules for method scope in that if you were to pass, say, like let's say, for example, you had made an integer k back in the class. Then you passed k to method 2 as a parameter. That variable k inside of method 2 would hide the private or the class level
Exactly.
k.
So what you're getting at here is it is following the same rules of a method-leveled scoped variable.
Where it will hide other variables.
Absolutely. So I want you guys to keep that in mind. And another thing that's a real interesting thing, and that is what happens when we get into a situation where, let's say, we create a variable, we declare it, but we don't initialize it until we're within some sort of structure, a loop structure, an if structure, etc. Ooh, that can be a problem that would make the compiler unhappy because what could... All right, let's do this. Let's focus on this area right here, and I'm going to rewrite some of this up above, if you guys don't mind. So follow me up here. So let's stipulate the following. So we're inside of method 2. We started out with x equals 3. We definitely know that was a problem. But I needed that is true to work. So if I created a bool is true, but I don't initialize it. Then I turn around and say if I is greater than 100, then if it is, now we're going to initialize. So is true equals true. Okay? Now, if I was to come down here, instead of assigning again, because this would serve as an initialization. But let's say I came down here and I did something like if is true. So if true ended up being set, let's do something, right? So I'm just going to come down here and do code. Check this out. And coming through, first of all, we know that that's a problem, so that's out. All right, so this guy right here, declaration, works beautifully. Now, with this guy in here being initialized for the first time, here's what happens. The compiler does not know if we're ever going to get into there. It just simply doesn't know. And since it doesn't know, it knows that it never gets truly initialized. Since it doesn't get truly initialized by us, now we know once this is all converted into intermediate language code, we talked about in the last video that when a method's called, the prologue code is going to create these variables on the stack and it's going to initialize them. But check this out. This is the compiler stopping us, not us getting to IL. As a matter of fact, if you were to get this into IL or just write this straight out yourself, you could make this work, okay? Because, again, it's going to be initialized as soon as the space is created, before the method even runs. So keep that in mind. It is the compiler that is stopping us here. So the compiler simply sees that, okay, this is where it gets initialized, but since it's inside this structure, it may never get here. Because what if I comes in and I is a 1? Well, then we wouldn't run this. So then we're going to jump down here to if is true. Well, is true was never initialized. That is a problem, right, Logan?
Right, because then, well, we'd have the same thing as if we tried any other case of trying to use a variable without initializing. If we just said bool is true and then if is true, we simply can't do that.
That's right. Let's demonstrate this real quick. So kind of absorb what I wrote there. Because once again, guys, we're just making stuff up on the fly here. I just want to add a little bit extra into the lesson. So let's jump on back down to method 2, and let's work this out a little bit differently. Let's go ahead and, right above the if, say bool is true, terminator. All right, now let's go down into the if, and just, take the declaration out. Very good. And then let's go and start a new if statement afterwards, and just if is true. And now let's do a console write line. And just say, we made it here, or something like that.
Say, we are here, or something.
Yep, beautiful. Terminator. All right, so once again, let me grab my pen. The only place, so this is declared, the only place is true is initialized is inside this if statement. The compiler is going to view this as, we don't know if we're going to make it inside this if statement or not. So as far as it's concerned, down here, is true never got initialized, okay? So let's go ahead and compile and see what we get. What do you know? It already underlined exactly where the problem is, coming down here, and it's even giving a description very similar to what I just said. Use of unassigned local variable is true. That's right, it's unassigned. It's not been initialized. So you may be thinking, well, if I'm in this kind of a situation, how do I make this work? Well, real simple. Just initialize the variable before you get into a situation where the variable would be initialized within a structure. So if Logan comes in here and says equals false, we have now initialized the variable. So it is irrelevant that it's being, well, it's no longer even being initialized down here. It's just being set if we end up in here. It has been initialized right here. Let's go ahead and hit F6 and make sure this goes away. Look at that. The error is now gone. The compiler is happy, and everything is ready to go. So I just wanted to point that out. That's really important. Now, this is interesting. This is only because the compiler doesn't know if we'll make it down in here. There are certain types of loops. Well, there is a particular type of loop that will have execution work one time. Okay, that is a do-while loop. That means we will do the contents of the loop one time, no matter what. If we were doing that particular case, the compiler knows that we would have made it through the loop at least once, and we could have initialized at that point. So that does work for us. A for loop, on the other hand, a for loop, well, we may not have made it inside, so that wouldn't work. A while loop, we may not have made it inside. That wouldn't work. If we had just done blocking braces, it would have also worked because the compiler would have said, we will definitely make it in there. But in this particular case, with an if statement, a for loop, and a while loop, we don't know, we being the compiler, if we're going to make it into there or not. So we have to assume that it never gets initialized.
Basically, it plays it on the safe side. It looks at it and then says there's the possibility that this might be uninitialized. And if it finds any cases where a variable could possibly be uninitialized, it treats it as uninitialized when attempting to compile.
Right. So Logan's using this possibly, and I'm just using it doesn't know. So same thing. All right. So Logan, is there anything else that you would like to add into this lecture on VariableScope?
No, I think that covers it.
All right, so with that, that is going to wrap this video up. Thanks a lot, guys.